So the last lesson that you did adding and subtracting fractions when they had common denominators. In 9.2, we're going to do adding and subtracting fractions with unlike denominators. So do your title and your table of contents. And here are the notes that you need to copy. And we're going to first start by looking at least common multiples because we have to have a common denominator. And so the least common multiple is what we would like to see in the denominator. So there's two different ways that you could do this with numbers. When you were younger, the way that they had you do it most likely is we'd list out the multiples of 15. So 15, 30, 45, 60, 75, 90, 105. We're not exactly sure how far we need to go here. We may have to add to this list a little bit. Then we need to do the same thing for 16. So we'd have 16, 32, 48, 64, 80, 96. Well, right away I can see we don't have anything in common yet, so I need to keep going with this list. 112, 128, 144, 160. Well, that's my first one that I might have hope. Let's try 20s. 20, 40, 60, 80, 100. Oops, that should be 140. And then 160. Okay, those two have in common. Hopefully then 160 is a multiple of 15 as well. So we're at 105, yeah, 120, 135, 150, and it's not going to work. Okay, so 165. Okay, so we're going to have to keep going through this until we find a number that matches. As you can see, this can become a very tedious problem like this. So a better way to do this is to do a factor tree and write this as prime factorization. So let's do 15 is 5 times 3. We can't do anything more with that, so 15 is just 5 times 3. 16 is 4 times 4, and you could break that up with 2 and 8. You'll get the same answer either way. And so this ends up being 2 to the 4th. And then 20. 4 times 5. 4 is 2 and 2, so 2 squared times 5. Now, what we need to do is write out each unique base. So we have 5 written twice, but we only write it as the least common multiple once. Then we look for another unique base. We've got a 3 here, so I put a 3. And then the last unique base would be the 2. Again, even though it's written twice, we only write it once. Then what we have to do is look for the highest exponent with each base. So we look at our 5s, and they both have an exponent of 1, so I just put a 1 with it. Or you don't really need to do that as well. Okay, so 3 has an exponent of 1. Again, you don't have to write that, but I'm just going to. And then we look at the 2's. This one's a little bit more interesting. We got a 4, and we have a 2. So you choose the highest one, which is 4. So now if we were to multiply those together, so 5 times 3 times 2 raised to the 4th, you get 240. So that would have taken us a long time listing those other ones out. But sometimes we have smaller numbers and it would work that way. Okay, now we have to do the same thing though with our letters, because remember we had letters as part of this problem. So we do each base, so we have an A, we have a B, and we have a C. And we do whichever one has the highest exponent. So A has A cubed as the highest one. B has B to the 5th. And C has C to the 6th. And so 240, A cubed, B to the 5th, C to the 6th. One way you can think about it is what is the other one missing that something else has? So this one, we need to get to match the highest one, which is right here. So it needs 4 more b's to be b to the 5th. That's the way we're going to want to think about this when we go to adding fractions. Okay, how about when we don't have a monomial, we have polynomials? what we're going to need to do is factor this as much as we can. So looking at the first polynomial, first of all, I see that there's an x in common. I'm going to pull that out first. And then we've got x squared minus x minus 2. Then you think about your t-chart and what adds to -1 and times to -2. So 1 times 2, and then the 2 needs to be negative and the 1 needs to be positive. Okay, let's do the other one then. This one we can start by just factoring it. X and x, what adds to 4 and times to -4, adds to -4 times to +4. That would be 2 and 2, and if we make them both negative. So now, the bases are any group. So this is considered a base, that's a base, that's a base, that's a base, and that's a base. And again, we write it out as each unique base. So if they show up twice, we don't write it down twice. So that x plus 1, and then we had an x minus 2. Even though we have more than one x minus 2, we just write it out once. Now, what's the most that excuse me, x shows up? And that's only this time right here, that's once. How about x plus 1? Just right there, that's only once. And x minus 2. Well, this one has one of them, but this group has two of them. Over here, there's two of them. So this one has an exponent of 2. This is our least common multiple. Again, those ones aren't necessary to write there. Okay, go to your left page and try that problem. And then try that problem. Okay, let's try doing one of these problems now. First thing we need to do is find the least common multiple. So we can think about 6 and 14. So this is a small one. We might be able to just write this out. So the multiples of 6 would be 6, 12, 18, 24, 30, 36, 42. I think 42 is going to work. On 14, we have 14, 28, and then, 42. So the number for our least common multiple is 14. But then we look at the variables. We write down each base, and then whichever one has the most. So A has an exponent of 2 as the highest, B has an exponent of 2. So that's what we need to have our denominators become. So how do we change 6b so that it looks like our least common multiple? Oh, I wrote that down as 14. Ignore that, sorry, that should have been 42. Okay, so the 6 needs a 7, and then needs 2 a's, and it needs one more b. Now you can't just change the denominator, you have to change the numerator as well. So whatever you put in the denominator, you have to put exactly the same thing in the numerator. Okay, it's 14. What do we multiply that to get 42? That would be by 3. And then we don't need any more variables, so we just need to multiply the top by 3. And then we'll rewrite this fraction. 35 a to the 4th b over 42 a squared b squared. And then if we add that to 9 times 3, 27, and 14 times 3 is 42, a squared b squared. Now we have common denominators, so it's like what you were working on the last homework assignment. So we can write 42 a squared b, and then since the numerators are not like terms, we can just write them next to each other. And that would be our answer. Okay, go to your left page and try this one on your own. All right, last example for this video. Okay, let's see what this least common multiple would be. We need to start by factoring the bottom. So 3x minus 15 is going to become 3x minus 5. 6x minus 30 becomes 6x minus 5. So the least common multiple is going to be 6x minus 5, because we could multiply that 3 by 2 to get 6. So all we need to do is take this first fraction and multiply it by 2, and then it'll match the second fraction. So we get 2x plus 20, make sure you distribute that in, 6x minus 30, minus 3x plus 15 over 6x minus 30. Okay, we have common denominators. Now we can go ahead and subtract. So make sure when you subtract, you're careful with this. It's 2x minus 3x, which is going to be a negative 1x. And then when you do 20 minus 15 is going to be a positive 5. Okay, let's see if we can simplify this down at all. So I'm going to factor the bottom, and you get 6x minus 5. Well, that looks very similar to the top, where it's negative x plus 5, except for its opposite signs. So we know what to do with that. We pull out a negative 1. We get x minus 5 on the top. You get 6x minus 5 on the denominator. And they'll cancel out. And so really this becomes negative 1/6. Okay, again, go to your left page and try this out. And once you're done with that, then that's the end of the first day of this lesson. There is more that you're going to be adding to this, so do not write your summary yet.